You're having an important business meeting well into the future. You're meeting someone for the very first time. They reach out to shake your hand and give you a warm smile before saying, 很高兴见到你. So for my non-Mandarin crowd, you have no idea what I'm talking about. And apparently, it shows on your faces. The man retracts a bit before saying, oh, what I meant to say was, it's nice to meet you. How could this situation have gone differently? Something we don't often think about is how crucial language is in all of our daily interactions. When you're going up to that super awesome professor at that conference that you've been waiting to go through for a month, you're making sure every single word that comes out of your mouth represents you well. This is because language is the key to making good connections. Even as a patient entering medical care, you want to be able to articulate what's wrong with you to your healthcare provider so that you can receive a precise diagnosis and urgent care. Bottom line is, translations are a huge deal. Something you may think of when you think of top-of-the-line translations is Google Translate. And that's rightfully so, because over 100 billion words are translated a day using Google Translate. That's over 1 million a second. In 2016, Google Translate underwent a makeover that greatly impacted their fluency. This makeover that they made was the introduction of a model called neural machine translation, or specifically a sequence-to-sequence model. The sequence-to-sequence model is characterized by an encoder RNN, a context layer, and a decoder RNN. A sentence in our source language is fed into the encoder, which then creates a context vector, or a set of numbers that accurately represents the meaning of the sentence, which is then fed into the decoder RNN for translation. On a high level, the encoder interprets or understands the input, and the decoder comes up with a translation. One thing I added to my model was an attention mechanism to add fluency. Attention is inspired by how human visual attention plays out in different regions of an image, or the correlation when you're reading words in a sentence off a piece of paper. The way the attention mechanism works is it assigns weighted number values to each word in the sentence, and this acts as almost a second context vector, which the decoder can then use to pay certain attention to words when translating or generating words into our target language. Now, this has recently been improved upon as a whole with something called the transformer model, which takes away some of the setbacks that are provided by RNN. But in my opinion, with translations like this, we still have a lot of work to do. The future that I see for NMT is a truly unburdened global economy, where giants like India, China, and South America can thrive and add as much value to humanity as possible. I see accessible healthcare that isn't dependent on whether or not you know the language of the region where you are, and potentially even BCIs that translate language for you before they would traditionally reach your ears. Nelson Mandela once said, "You speak to a man in a language he understands, it reaches his head. And you speak to a man in a language that he knows, in his language, it reaches his heart." And for these reasons, I believe NMT is the key to language minus the barriers. Thank you.